start with a question about system reliability. What does that term mean to you, system reliability?
It's a really important aspect of designing any research facility is how reliable does the HVAC electrical systems need to be to support the science? And when I talk about reliability, I like to think of reliability in simple terms. How many of one thing do you need to support that activity? So I'll use the example of an air handling unit where the air handling unit provides 100% of the air to a room, and you could do that with two units at 50%. You could do that with three units at 33%. You could do that with four units at 25%. And you could see how, as you lose one of those units or one of those units fails, you have a higher level of reliability or capacity in the event of a failure if you have four at 25%, and so on down to two at 50%.
What do you think is important for people to understand about reliability?
I think the important thing about reliability is making sure that you understand each component of the system. So when I talk about air, you're talking about one aspect of the HVAC systems. That could be the temperature control in the cooling season that moves the air. It could be the heating. It could be the dehumidification cycles. So each one of those components, not just the fan, not just the air handling unit itself, it may require multiple components to be designed with a reliable um, reliability factor associated with it. So one might need two at 50% and one might need three at 33% to reach an overall goal for system reliability. So it's important to understand that as things break or fail, when is the research lost? When are you really losing money or time associated with that failure? And can you use 50% of the air in the case of an air distribution system and still maintain sound, stable research?
So I've heard the term reliability before, but I've also heard the term redundancy before. Is that a phrase that's interchangeable with reliability? If not, what's the difference between a redundant system and a reliable one?
Perfect. The main difference is when in a reliability factor, and again, I'll use the two at 50%. If you lose one of those units, you have 50% of the capacity. In the case of a redundant system, you would have two at 100%, in which case one fails, you have full capacity. So it can cost a lot more to be fully redundant. So a lot of projects and labs will evaluate their critical need and sometimes find that reliability design or design for a reliable solution is just as is more cost effective and in alignment with their needs than redundant systems.
What I'm hearing is that redundant systems are going to be a little bit more expensive, but they offer a higher level of security. Is that a safe assumption?
Very much true that the redundant systems are going to provide a higher level of both reliability and security in knowing that when something fails, you don't lose any research. And the nice part about the control systems today is that you have really smart and reliable sensors that will detect failures, and those failures can automatically indicate on a dashboard or at a BMS or at a user interface so that the users know that the redundant system is now started.
So we've talked a little bit about the relationship between reliability, redundancy, and cost, but what's the relationship between a redundant system, a reliable one, and energy efficiency? It feels like energy is at the center of a lot of conversations these days, so I wanted to make sure we touched on that point.
In the case of a redundant system, if you have two at 50%, you're going to need to run that air handling unit system, again, back to the air handling unit analogy, at two of them run at 100%. If you have a redundant system where you have two sized for 100% of the capacity, you're typically able to run those two units at a 50% operating point. And when you run larger equipment at 50% capacity, it typically runs at a more efficient operating point. So it allows you to save energy over the life cycle of that particular system or that facility. And In most cases, you would need to do a return on investment evaluation, decide if it's the best solution to go with a fully redundant system. But a lot of times it can pay for itself, return on investment based on energy savings.